Hey, how's it going? Hey, today we're going to take a look at this new 300 amp hour 12 volt lithium iron phosphate battery from EPOCH Batteries. Now, if you were to look at the spec sheet for this battery, you'll see that it's got pretty much all the features that they've been putting into batteries over the last few years. It's in here, and a lot of that stuff's listed here on the front sticker of this battery, but not everything, and we'll talk about it here in a second. The most notable features of this are that it's a group 8D formatted battery. So if you have an 8D size battery box, then this will fit inside. It's also got the Victron Communication support built in, and we'll talk about that. It's IP67 rated, so it's waterproof. It can be used in a marine environment. And also, this one caught me by surprise. It's rated as a dual purpose battery. So you can use it to crank up an engine and as a deep cycle battery all in one. If you look at those features, you might be thinking, hey, this is really similar to the other battery that EPOCH has, which is their 460 amp hour battery that's got the Victron Communications. It's IP67 rated. So that was my assumption going into this, thinking it's going to be just like that, but just at a lower capacity of 300 amps. But when I got this, I was going through it, and I noticed that there are a lot of differences that I want to talk about. I've been spending the bulk of this week just kind of going through all those, trying to flush all those features out, figuring out how they work, so that I can share it with you. But I've cycled this battery several times and done some testing. I'll try to crack this thing open. We'll give us a look inside to see what the build quality is inside the box here. All right, now before we jump in, I do want to mention that that links and additional information about this battery are going to be in the video description. So if this is something you're researching and are interested in, go down there and check it out. But yeah, you can see that with these two batteries, this is a 460 amp hour model, and this is the 300 amp hour model. So, you know, the biggest difference obviously is that there's a difference of 160 amp hours of capacity, which you would think that, yeah, this would be a bigger battery. Initially, it looks like they are, but are they really? If we flip this 8D battery on its side and do this, you'll notice that they're pretty close. You know, they're just different shapes. So obviously this one's taller. It's got some more branding here. You can't really tell because it's dark, but there we go. It says EPOCH and all this stuff. This one's a little more plain. And they both have these straps that we can obviously remove when these are mounted. You don't need to have these in here. You can easily slide these out of the little socket here and take them out. On the 460 amp hour version, it's got these mounting holes, these threaded holes. So if you wanted to anchor them down, that you already had these anchor points here built in to the case. This one does not. Now, one thing that I noticed that isn't obvious because it's on the bottom, this one has this kind of cool honeycomb texture to it, and I'm not sure the function of it, but I would think if you put it on a surface that's a little bit soft, that this thing is going to be really solid. It is not going to move, and maybe it just helps keep moisture, you know, from touching the bottom of the case. But yeah, something I just noticed, this one is just smooth on the bottom. There is a difference in weight. The 460 amp hour battery is, I think, 96 pounds, whereas this 8D one is 85 pounds or 82 pounds. Yeah, I think there's like a 14-pound difference. So I expect that when we crack this this 300 amp hour one open that we would have a little extra space inside to so not everything's all crammed so tight like this one, but we'll see when we open it up. Now, by the way, the reason I'm going through this comparison of these two batteries is because I'm guessing that if you're looking at this battery, that you're probably also considering this 460 amp hour one too, and you're probably trying to piece together what are the differences and why would I choose this over that, or vice versa. So, you know, hopefully this comparison is going to help you out. If we take a look at the top, I guess, of these two batteries, we can start to see some differences here. One of the big things we've noticed right off the bat is this this heat sink that's right on top of the BMS. Once we open up the top, we'll see this. But look at the size of this one on the 460 amp hour battery. You know, it's about, you know, just less than the size of my hand. But this new one here on the 300 amp hour battery is more than twice the size. So from what I saw while I was doing some discharge capacity tests and stuff, is that, yeah, this does a great job of releasing heat. So I imagine the temperature control of the BMS and the battery is probably a little bit better on the new one. Now the power button here on the new one, you can see here it has a little silicone little cover for it, and it's a push button on-off switch that activates the BMS. You can see it's on right now. You can see our state of charge. Now the other one, you have to kind of press and hold this button. It's a little different. You have to hold it for a while and then it comes on. And it's got like a plastic cover on top of this other section here on the original one that has like dip switches here, which are used to set some modes and set battery indexing when you have multiple batteries. Now, when on the new one here, this one doesn't have any dip switches, which is interesting to me. So how does this identify individual batteries? Well, I'll show you how that works when we get to it. But the other thing is that we can see on the new one here, we've got extra terminal posts. So these are M8 bolts, and it does come with 4 of these bolts. I've got 2 of them in use right now. But each terminal has 2. So we've got 2 negatives and 2 positives, and this nice little rubber cover here when you're not using it. But this comes into play when you're connecting multiple batteries together. You don't have to stack your lugs, your cable lugs on top of each other here. You can just attach them to this secondary point here, the secondary post. So 1 on each side, so that's really nice. The original one just has 1 positive and 1 negative. Now the other thing we start talking about are communication ports. On the new one, we have new connectors. So these are like these little 6-pin connectors. That's completely different from what we have on the old one, which is a different style connector. On this one here, we have 2 RJ45 connectors. Let me move this around so we can see it. But if you watch the previous video or you have one of these, you can see the difference. So these are protected by these caps, but this is basically like a network style connection that we plug into here, which is completely different from what we have on the new one. That you can connect up to 4 of these in series to get like a 48 volt max power output. So you can create a 48 volt bank out of 4 of these, but you can also connect up to 16 of these in parallel to keep it at 12 volt and, you know, really get a lot of extra capacity out of that. Okay, it does come with a couple of communication cables that we talked about, an extra set of M8 bolts for these, and a few extra caps and stuff that we can use to cover these up when we're wanting to protect them. All right, so one more thing that I'll point out here is that on each of these cases, there's a pressure release port. So as there's any pressure buildup or anything inside due to expansion and contraction, you know, with things heating up and cooling down. So this one also has a pressure release, and it's right here on the front. It's a little bit smaller, but it's just in a different spot. All right, now let's see if we can get this open and take a peek inside. Now this is not something I recommend you doing. It may actually void the warranty. There's a little sticker back here that kind of keeps it closed. But I don't have a problem doing it, so you can get a peek inside so you don't have to do it if you're curious. But the lid looks like it does come off. It's got these little rubber inserts here that cover up the little hex bolt that attaches these together, and there's probably a weather seal in here and all that. So this little rubber piece just keeps any moisture out of here. So just pop all those out, and then we'll see if we can gradually, carefully take this top off. All right. Well, look at that. Really nice. Let's see. So what's interesting about this is that all the circuitry, the main BMS board, this looks like yeah, just a lot of control circuitry here and switching. Everything's mounted to the top lid. So there's nothing down here except yeah, it looks like a heating pad and the battery cells. So let's start up here, see what we got. Okay, so it looks like our main BMS board here, very nice and streamlined. Yeah, we've got our negative bus and the positive on this side. Yeah, so interesting observation right here off the bat is if you remember looking at the 460 amp hour battery from EPOCH, it had a really big fuse that was attached to the positive side of the battery. Now this one doesn't have that. It doesn't appear to be any kind of fuse that's built into the battery itself. So keep that in mind when you hook it up, that you're going to need to incorporate, you know, some overcurrent protection when you set this up. Don't assume that there's a big fuse in here, because there isn't. Yeah, very streamlined, very clean. I like the look of this. We can see all of our different connections. We've got our communication ports here. Everything comes into this this controller board, and it looks like this next set of wires here looks like that goes to temperature sensors. There's looks like there's 4 here, so there's probably 2 temperature sensors that go down into the battery cell compartment here, and one goes this way, one goes that way. So it looks like there's also a temperature sensor on the positive bus bar here where the terminal posts are, and another one here on the negative bus bar for the terminals. So interesting as well, like all of these little all these little bolts are covered with this little plastic cap. So each has a little plastic cap that I guess protects any metal from touching other metal, which could be a bad situation. But yeah, if we look up here, we've got our stated charge little meter with our little control switch and our power button here. You can see that goes all the way to our control board here. So this is our power. These connections, we've got 2 positives and 2 negatives, and if I follow that around, I believe that controls the heating pad. So yeah, this is a heated battery. According to the documentation, that it automatically tries to raise the heat up to 10 degrees Celsius, so that's about 50 degrees Fahrenheit, as soon as you attach a charging source to it, so that automatically will bring the temperature up to, you know, around 10 degrees Celsius before it starts charging. And I can see here that there's a little temperature switch. I'll show you that in a minute. That probably is what controls that. Okay, so that's what's in the lid here. All right, we can take a quick look at the bottom here where all the cells are. We can see that everything's really nice and secure in here. We've got a nice metal bracket with ample space around the sides, which is nice. Which, remember I mentioned I wasn't sure how much extra room we're gonna have in here, but it looks like there's plenty of room to make sure that this whole thing is really nice and secure and not so crammed in this box. So we've got these braces on the top. These little, oh yeah, these little white caps here. So covering this little bolt. It looks like the bolts are marked and torqued and everything. So yeah, nice to have these little caps to minimize the metal to metal contact. And this orange thing, it looks like this is a heating pad. So as I mentioned before, I'm guessing that there's a heating pad here on the top and there's a heating pad on the bottom. Now we've also got this switch here. See, I thought it was just a temperature sensor, but it's actually connected to the power line that goes back here, which is what powers this heating pad. Let's see if we can, oh yeah, it comes up. It's just a little adhesive on there. We can kind of see what kind of cells we have here. I'm not going to lift it too far, but enough to see. Okay, so we've got, you know, these skinny cells. So it looks like, yeah, it looks like the bus bar and all the connections are on this side here. It's hard to see. I won't be able to show you in the camera, but there's looks like a bus bar connecting 3 of these. So it appears that there's like 12 of these cells. So 1, 2, 3, probably 4, 5, 6, and then 6 more. So that would indicate to me that let's see, to give us our 13.4 volts or so, that means we need 4 groups in series. So if we take 3 of these and connect those in parallel, so we have 4 virtual cells, each one has 3 cells in parallel, if that makes any sense. So yeah, so put this back here. Yeah, we got a nice plastic case, looks like holding all the cells together, and then this metal bracket that just kind of squeezes everything together. Everything's torqued down, very clean, very nice. Yeah, I like this. Okay, well, our battery is all powered up, reconnected, and yeah, hooked up to our inverter and all that stuff. And we'll get to some load and capacity tests here in a sec. But I want to quickly just run through the Victron Communication setup for you. I know that's something you're probably interested in. So it comes with a couple cables, and this is the one that we want to use. This is the cable that we're going to connect to the servo or whatever your GX device is. It has a RJ45, like a standard network connection on one end, and this 6-pin connector that connects to the battery on the other end. Now the other cable that it comes with is this one here. It's got 2 of the 6-pin connectors, and we're going to use this primarily if we wanted to connect multiple batteries together. Now the one we're going to use to connect to our GX device is going to be going into the link in port. So we're going to take our end that's labeled battery and connect it to that link in port. and just kind of line it up. There's a little tab in there. Make sure you connect it, line it up right, and then once you can get it seated, then you can tighten down the little tightener there. And then the other end, we're gonna take this like our network RJ45 end, and that's gonna plug into our CAN bus port on our GX device. Now I have an older GX device that I use for testing, and that's what we're using today. Some of the GX devices like the Serbo and other Venus devices may be labeled differently. It could be CAN, it could be CAN BMS. Then what we have to do is go into our GX device and in the settings, and we have to set up the CAN bus port so that it's set up for a CAN BMS communication protocol. So the CAN bus can be used for multiple things, so we need to just let it know that we're using it for BMS communication. So once you have that set up in your GX device, it's still not going to show up in your device list. What we have to do now is here back on the battery, which is kind of interesting and different than we're used to. Alright, to activate the communication on this battery, what we have to do is go to this config button. Now this is the little panel where we have our state of charge that will be displayed when we're drawing a load and all that, and there's this little config button. Instead of having these dip switches that we would index individual batteries, like this is battery 1, battery 2, battery 3, there's no dip switches here. It's just all automatic. But what it does is it'll actually automatically go and search whatever's connected and assign all of those IDs automatically. But you have to activate it. Now in this case we only have one battery, but you still have to go through this process. So in order to do that, we need to go to this little config button here and press and hold it for 10 seconds. You'll hear it click. There we go. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Maybe I let go. Okay, yeah. So yeah, once you let go after 10 seconds, it starts, see, it starts cycling. It's got this little light pattern here. So basically it's searching. And it's going to go do this for a little bit, and it's going to automatically index your system in the BMS so that it identifies the batteries appropriately. In this case, it's probably just going to assign this one to battery number 1. And we just wait for that to finish. Okay, so we've got our state of charge indication here, so our communications is now activated. Okay, now once the communication is enabled, we'll see it pop up here in the device list on our GX device, and then we can look at the details of the battery that's being reported from the BMS, and we can also see it on our little status screens, and right here. So we got 91%, 13.3 volts, no amps, we're not doing anything right now, and yeah. So now we're connected and we can do whatever we need to do on using our battery with the rest of our system. Now if this looks a little weird to you, it's because I just updated to the version 3.5 of the Venus OS, so it's got a new user interface. So if you haven't done that firmware upgrade, go check it out. It's pretty cool. Alright, now the first thing I did when I unboxed the battery was to hook it up and run a series of capacity tests on it, just to make sure that I could pull 300 amp hours out of the battery and then I could charge it back up. I've cycled it a couple more times since then, and it's been completely fine with no faults. Now I want to do a maximum discharge test just to verify that we can pull the maximum rated current out of this, which is I believe 300 amps continuous. It does have a really high surge current, which is there to accommodate, I believe, this dual purpose function, which is to handle like the cranking of an engine, and that rating is up to 1,000 amps, which is only for like 5 seconds though, and I think it can go down a little lower for 10 seconds. So if you think of your engine starting, it's like, you know, how long does that last? You know, that's there to accommodate that. So that is pretty high. I have no way to test that right now. What I can do is try to push 300 to 400 amps. Try to pull that from the battery, and we'll see how that goes. Now, to monitor the battery during the test, we're going to use the EPOCH Battery Pro app. Now you can download that from, you know, for Apple or Android. You would go down to the air connection. You should see the battery pop up here in the list of devices. There we go. Okay, so yeah, it loaded the battery. We can see what we're currently reading. We're not pulling any current right now, but capacity is 300, and yeah, it's been cycled a few times, and we got 13.4 volts. And if we go to details, we can see all the different things that it's checking for, and we've got our individual cell voltages. So we'll just kind of look at this screen here, and we'll be able to watch our current draw. All right, let's go ahead and start our test. We'll start by turning on our inverter. Yep, okay, so it's just pulling about 3 amps. This is a 3000 watt inverter. And let's add 100 amps. Start with that. Okay, yeah, we're looking at 100 amps there. I can hear a little bit of a hum in the battery. Let's go ahead and add another 100. Okay, 225 total. I don't know if I can really dial this in too precisely to get right up to 300, but we'll see what happens when I turn on another one of these. We can go to a little over 300, see what happens. This might put us over though. Oh, 350. So that should probably throw an alarm here. If I look at our log, okay, we're getting a warning for 350 since we went over 300. I dropped it down to 235, so we should be good. It's giving us another warning. Okay, we're up to 343 now. It's handling it okay, but it's probably gonna shut down here any second. Okay, there it goes. So yeah, it took it for quite a while before I got a warning. So now I got the GX device that's basically alerting me. So that's working. So I'm gonna silence the GX notification, and yeah, now if we look at the log here, we got our, remember we kept adjusting it a little bit, we would get a warning, and then it released, and then another warning when it was fluctuating between 345 to 200 and something, and then the final one was a discharge overcurrent protection, which is what reset everything. So the recommended discharge current on this battery is 150 amps. Like we saw, the maximum is 300 amps that will actually trigger an alarm. I'm curious to see how you use this, and I'm also curious to know if you have an application for this dual purpose mode, you know, as a starter battery as well, and how that works out for you. So I hope you found this helpful, and yeah, let me know how it goes, and thanks for watching, and I'll catch you in the next one. It's 76 to 80 degrees on the top, which is that heat sink's supposed to be doing. Alright, I hooked up a second charger here, so I'm putting in an additional 40 amps. Actually, yeah, 40 to 50 amps. In addition to the 80 or so that I'm doing through the inverter. So if we look at the app here, it's putting in 125-ish amps right now. And so it's about 1600 watts. It says that's going to take about 2 hours and 18 minutes. So we'll come back and check on it.